If there's one thing we all know about space, it's that things out there can get big, really, really big. In fact, some objects in space are so huge that they defy explanation and truly make our human head swivel in amazement. We are small creatures, so even something the size of a modern skyscraper can make our jaws drop. Now, imagine something that is not just the size of one galaxy, but multiple galaxies bound together. That's when you start to comprehend just how massive things in the universe can get. But what's the biggest of them all? What makes other cosmic structures pale in comparison? Let's take a look at what NASA says is the largest structure in the entire known universe. Before we get to the biggest, we need to do a size comparison so you can truly understand the scale of the universe. The largest asteroid recorded is Vesta, which measures around 330 miles across and is located in the asteroid belt between Mars and Jupiter. The largest planet in our solar system is Jupiter, which is about 88,800 miles in diameter, roughly 11 times the size of Earth. But even that isn't considered large when talking about the scale of the universe. Before we get to the biggest, we need to do a size comparison to understand the true scale of the universe. The largest asteroid recorded is Vesta, which measures around 330 miles across and is located in the asteroid belt between Mars and Jupiter. The largest planet in our solar system is Jupiter, with a diameter of about 88,800 miles, making it roughly 11 times the size of Earth. However, if we want to think beyond planets and stars, we need to start considering galaxies. A galaxy is a collection of star systems and everything inside them, including planets, asteroids, gas, dwarf planets, and more. Our home, the Milky Way galaxy, spans about 100,000 light-years across, but even that isn't considered large on a cosmic scale. The biggest galaxy on record is IC 1101, which is about 50 times the size of the Milky Way. Now, if you think a galaxy is enormous, just wait until you hear about galaxy clusters. A galaxy cluster is a group of galaxies bound together by gravity. For example, the Milky Way is part of a small local group containing around 24 nearby galaxies. One of these clusters is a supercluster called the Hercules-Corona Borealis Great Wall, which is now considered the largest supercluster and structure in space. Discovered in 2013, this structure has been extensively researched and is so massive that light takes 10 billion years to travel across it. To put that into perspective, the entire universe is only 13.8 billion years old. The Hercules-Corona Borealis Great Wall was discovered by a research team led by István Horváth from Hungary's National University of Public Service while studying gamma-ray bursts, powerful cosmic events believed to come from supernovas or massive stars exploding at the end of their lifetimes. Since these bursts tend to occur in dense regions, they help scientists locate massive amounts of matter in the cosmos. The first scan revealed gamma rays concentrated 10 billion light-years away, in the direction of the constellations Hercules and Corona Borealis. This discovery confirmed the existence of a colossal structure. In fact, the Hercules-Corona Borealis Great Wall is so large that it challenges modern astronomy. Cosmology is based on the principle that, on a large enough scale, matter in the universe should be evenly distributed. However, astronomers can't agree on what that large enough scale is, but whatever it is, this Great Wall exceeds it. Because of its great distance from us, this structure must have existed just 4 billion years after the Big Bang. In the grand scale of the universe, nothing gets bigger than the Hercules-Corona Borealis Great Wall. The Hercules-Corona Borealis Great Wall may be the largest known structure in the universe, but there are certainly other objects that come close and make our size seem insignificant. One such newly discovered space structure is called the Giant Arc. The Giant Arc is a vast collection of galaxy clusters and other cosmic objects that stretches 3.3 billion light-years across, covering over 7% of the known universe. It is one of the largest formations ever found, and its existence challenges some of astronomy's most fundamental principles. This massive and spectacular gathering of galaxies was discovered as part of a larger study aimed at surveying the farthest reaches of the universe. The research involved mapping thousands of distant quasars, bright, compact galactic centers so far away that they appear as tiny points of light through telescopes. As light from these quasars travels toward Earth, some of it is absorbed by atoms in the galaxies along the way. By studying these absorption patterns, scientists can infer the presence and composition of galaxies without directly imaging them. During this research, Alexia Lopez, a British PhD candidate, noticed patterns in the data that hinted at something more. After reviewing her findings with her advisors, one of them, Roger Klaus, suggested running statistical tests to determine whether the giant arc was a real physical structure or just a chance alignment of objects. Sometimes, stars and galaxies appear to form patterns from Earth's perspective even though they are unrelated in space. Once the tests were completed, the results showed there was only a 0.0003% chance that the giant arc was not real. If confirmed, this discovery would challenge Einstein's cosmological principle, a fundamental idea in astronomy that has shaped our understanding of the universe for nearly a century. In simple terms, the cosmological principle states that when viewed on a large enough scale, the universe should look roughly the same in all directions. It also suggests that the largest real structures should be no more than 1.2 billion light-years across. This concept, introduced by Albert Einstein to simplify mathematical calculations, has been so successful in explaining the cosmos that astronomers have been reluctant to abandon it. However, if the giant arc is real, it could overturn cosmology as we know it. That's why scientists around the world are carefully analyzing Lopez's findings to determine if she has truly reshaped our understanding of the universe. So far, the evidence is strong, meaning that the giant arc and its astonishing implications for the cosmological principle may soon become accepted scientific reality. If confirmed, the giant arc will join the Hercules-Corona Borealis Great Wall and a growing number of other massive cosmic structures that challenge the mainstream model of cosmology. This model assumes that, on a large enough scale, matter in the universe is distributed uniformly. However, the giant arc appears to be 3 times larger than the theoretical limit of cosmic structures. The discovery of the giant arc adds to a list of mind-blowing cosmic structures, including the Sloan Great Wall, the giant gamma-ray burst ring, and the huge large quasar group. These discoveries are expanding and reshaping our understanding of the universe in ways that were unimaginable just a few decades ago. There was a time when the idea of something larger than a galaxy was unheard of. Later, the idea of structures rivaling galaxy clusters seemed impossible. Now, scientists continue to uncover even larger and more complex structures in space, making our universe appear even bigger and more mysterious than ever before. Thanks for watching another episode. While you're still here, click the video on your screen for more high-quality content about space. I'll see you there.